An animal with 3 hearts, blue blood that transports oxygen in cold waters, and a decentralized nervous system unlike that of any mammal. The octopus is an evolutionary outlier, capable of dynamically changing its skin color and texture in an instant. They solve complex puzzles, use discarded coconut shells as tools, and escape from secure enclosures through openings barely larger than their beaks. In the animal kingdom, high cognitive function usually requires time. Elephants and parrots use their large brains to navigate complex social structures and environments over decades. Based on its massive intellect and complex biology, the octopus appears built to survive, learn, and adapt for many years. In reality, most octopus species complete their entire life cycle in just 1 to 2 years. Some smaller species live for only a few months. This creates intense time pressure. Every decision matters because the animal has very little time to grow, hunt, and learn the layout of its environment before its mission ends. Yet this presents a clear evolutionary contradiction. Developing a massive, complex brain takes immense biological resources. This raises the question of why natural selection would invest so heavily in an intelligence that lasts for such a short window of time. For the octopus, this high intelligence functions as a high-speed engine, rapidly driving them toward one final reproductive mission. The octopus spends the vast majority of its life in isolation, but as adulthood approaches, a biological instinct overrides that solitary nature, forcing them to seek out a mate. This encounter is dangerous. An octopus cannot assume another of its kind is friendly. If approached incorrectly, large females have been observed attacking and eating smaller males. To manage this risk, the male uses a modified arm called the hectocotylus. He extends this arm to transfer a packet of sperm, the spermatophore, into the female's mantle, allowing him to maintain a safe distance. The male approaches mating as a high-stakes calculation, where the drive to pass on genes outweighs the immediate risk to his own life. Once mating is complete, the male stops feeding, his movements become slower, and his body begins to weaken. For decades, biologists attributed this decline to physical exhaustion from the reproductive process. However, research into the octopus endocrine system identifies a different cause. Positioned near the brain are the optic glands. These glands release a flood of hormones, initiating senescence. This chemical signal alters metabolism and triggers a rapid physical decline, a biological kill switch. This programmed anatomical sequence removes the male from the ecosystem, ensuring that resources remain available for the next generation. While the male's journey ends, the female begins her final act. She finds a sheltered den beneath rocks or coral where she lays tens of thousands of eggs, sometimes over 100,000 at once. From that moment on, she stops hunting. Every hour is dedicated to cleaning the eggs and fanning them with oxygen-rich water to ensure they develop. In colder environments, this brooding period lasts for years. One deep-sea species guarded her eggs for over 4 years without leaving to find food. To sustain this vigil, the mother metabolizes her own muscle tissue and internal reserves. Her strength fades as she gives her remaining energy to her offspring. She continues this care until the very end, often dying at the exact moment the eggs begin to hatch. Thousands of miniature predators emerge and jet into the open ocean. They are born with 8 arms, large eyes, and the instincts required to survive. They enter the water column with no parents to guide them and no safe home. They are entirely on their own from the first second of life. Ocean currents carry them into the plankton layer, where they become prey for fish, seabirds, and jellyfish. Only a tiny fraction will survive long enough to reach adulthood. The sacrifice of the parents provides these offspring with a brief window of opportunity in a hostile environment. We are left with the central evolutionary question: why did nature produce such a complex brain for an animal destined for a short, one-time mission? One theory suggests that intelligence was the only viable strategy for an animal without a shell. Without physical armor, octopuses depended on flexible learning and rapid problem-solving to survive predators. Another possibility is that their short lives intensified natural selection. With only one chance to reproduce, any mental advantage that allowed them to live just long enough to mate became a life-or-death necessity. Intelligence functions as a specialized survival weapon, allowing the octopus to navigate a life defined by speed and vulnerability. They are the result of hundreds of millions of years of evolution, an animal that successfully navigates the ocean floor without ever needing a backbone. The octopus remains a testament to the rewards of finding a different way to survive. In a world of strength and armor, they thrive by being the ones who can think differently.